Hi, this is Rick for EDU Mobile. Now we're going to talk about methods. And I will say that we've already mostly talked about methods. Everything we talk about with functions in Swift applies to methods, including things like closures. Functions and methods are both really specific types of closure. And so we can do everything that we would do with functions with methods in Swift. So here we go. Methods are functions. Methods are functions, though, that they're special functions. They're functions that belong to an entity, an enumeration or a structure or the class in which they are defined. Fundamentally, there are two different kinds of methods. There are instance methods, which, as the name implies, operate on an instance of a type, and they have access to that instance's properties, and type methods, which operate on the type itself, and they only have access to static properties of that type, but not to properties of the instance. All right, so type methods are the same concept as class methods in Objective-C or static methods in Java. In fact, we use the static keyword to define a type method. So the first thing we want to talk about with methods as opposed to functions is the idea of self. What is self? Within an instance method, self is this instance. It refers to the instance itself. Now, in most cases, it's not necessary to qualify a property with self as it is in Objective-C. And this is because there is no iBar backing a Swift property. If you say, let's say we have a class or a struct or something that has a stored property called myProperty. In the methods, you don't have to say self.myProperty to distinguish between accessing it through its setter or getter and it's accessing it by its iBar, because there is no iBar backing in Swift. But in some cases it is required. The two cases it's required, the biggest case is when a parameter name in a method is the same as the property name. Then we have to use self to refer to the property name because the parameter name takes precedence. The other case is pretty much anywhere else the computer complains or the compiler complains about ambiguity. We don't know, if the compiler doesn't know how to get to the property, it's going to complain, and you'll need to resolve that by using self. So those are the two cases. Now that we've talked about self, how else are methods different than functions? Well, they operate a little bit differently when it comes to external parameter names. By default, the first parameter of a method is not externalized, but all other parameters are. Now, if you recall, when we talked about functions, we talked about external parameter names, and you had to explicitly define any external parameter names that you wanted. With methods, the first parameter name does not get an external parameter name, but all the rest of them do. Now, two ways to change this behavior. First of all, if you want the first parameter name to be externalized, you either precede it with a hash or provide an explicit external parameter name for it, just as you would for a function parameter. The other thing you can do is opt out of the externalization of one or more parameters, the second and further parameters, by giving them explicit external parameter names of underscore. That will unexternalize it. In other words, you don't have to use that parameter name when you call the method. Okay. How else do they differ? Well, instance methods that happen in enumerations and structures, for the most part, behave like instant methods in classes. The exception is when an instance method modifies self in some way or modifies the property of an instance. Now, the reason this is different in enumerations and structures is because enums and structs are value types, whereas classes are reference types. When you have a method in a class that modifies some property of self, you can just go ahead and do it. But in an enumeration and a struct, if you want to modify a property of the instance, then you must precede the method with the keyword mutating. So we have mutating func whatever. And so that will allow a method to modify the instance properties of an enumeration or a struct. There are special methods called initializers. These are special methods that are called to set up initial values for an instance, for a class, a structure, or an enumeration. If a structure or class has a stored property that is not given a default value when it's declared, that class or structure must have an initializer. An initializer is named init, and it doesn't have the keyword func in front of it. It is a method, therefore it is a function. It's named init, therefore the compiler sees it as an initializer. Now, can it be named init with A and B like we have in Objective-C? No, it has to be called init. All right, so more about initializers. All of the parameter names, if you have parameter names of an initializer, are externalized by default, including the first one. You can define multiple initializers for a class or a struct or an enumeration with different parameter lists. But you can't have multiple initializers with the same parameter list. If the types differ, if the length of the parameter list is different, you're okay. If all of the stored properties of an instance are provided default types, and if there is no provided initializer for the type, Swift will give you a default init initializer. How do you call init? Well, you don't call init. You just provide the entity name, the class name, the type name, or the structure name, whatever, with a set of parentheses. If init has parameters, you provide the parameters there. And again, if init has parameters, they're all externalized. Also, Swift's initializers don't return a value. Think about Objective-C for a minute. In Objective-C, we have init, or init with blah, blah, blah. We must return a value of type ID. Swift's initializers don't return any values. Also, Swift's initializers are not required to call through to super. They can. If your class is a subclass of some other class and you want to inherit the behavior of the superclass's initializer, you can certainly do that. But remember, if you define a new class, it is not a subclass of NS object. There is no such thing as a concept of a ultimate root class in Swift. So you aren't required to call through to super to get back to that ultimate root class instance's init method. Okay. So they don't return a value, and you don't call through to super unless you need to. On the other hand, a class can have a deinitializer. This you would use if you need to perform some teardown work right before a class or an instance of a class is deallocated. And the deinitializer is called dinit. Now, dinit doesn't have any parameters. There can only be one within a class, and it will always be called when an instance is about to be destroyed, right before the destruction, the teardown of that class happens. So you really only need a deinitializer when you want to perform some work to tear down the class.